A data warehouse pulls together data from many different sources into a single data repository for analytics and decision support. The main purpose of this is to create a draw of historical data that can be retrieved and analyzed to provide a useful insight for many organizations into their day-to-day activities.
Storing, analyzing, and index data. And data warehousing significance is undeniable today. A modern data warehouse is a cloud-based system that collects and keeps that data. This data can be used by organizations to help them make wise judgments.
So before we start, let me ask you a question. How do you store your data, or do you just store things like your clothes, books, or just simple memories? Do you know that just like cabinets and libraries, there are more like data mart, database, data warehouse, and data lake that can store and manage your data without any hassle? Yes, they are existing. And so, let's find them out. So to start, let's discuss database. So database is a digital filing cabinet that stores structured data and can be accessed using specific software. It plays a key role in managing large volumes of structured data and provide quick access, easy search, sort, and retrieval of information. The common types of database includes relational, SQL, and the object-oriented database.
So next up is a data warehouse. So a data warehouse is like a large library that holds data from various sources and helps in analysis and reporting, as it handles diverse data types and has tools for complex queries, analyses, and generating reports. So it supports real-time analysis, making it perfect for quick decision-making and business operations. So now let's proceed to Data Mart. So Data Mart is like a small store that caters to the data needs of a single department. It is simpler and quicker to set up than a full data warehouse and suits organizations with distinct departmental data needs. So Data Mart are valuable for tailored storage and analysis solution for specific departments. So lastly is the Data Lake. So Data Lake is like a giant pool that holds all kinds of raw data in its original format. It handles large volumes of unstructured data and is ideal for big data analytics and machine learning. It can also store unlimited data in various formats and supports real-time analysis, making it suitable for real-time big data analytics and machine learning. Always remember that data marts, database, data warehouse, and data lakes are all systems for storing data. But each have their own special uses which we can take advantage of.
Good day everyone! Today we're delving into the world of a data warehousing, a must-have system for any organization in order to measure their business performance. Join me as we uncover the features and the architectures that make the data warehousing an essential tool for business. To further understand the architectures of a data warehousing, we have here a scenario. Imagine a large enterprise with diverse data sources, operational databases, customer feedback, sales record, and more. Data sources act as the lifeblood, providing raw data from various aspects of the business. As for the integration, the first challenge is to seamlessly integrate these various data. The extract, transform, and load, or the ETL operation, come into play here, harmonizing these data types of structure for consistency. Once the data is integrated, data needs a home, and it will now enter to the storage layer. Structured storage methods, commonly relational databases. It stores the cleans and the converted data. This provides not just an effective storage but also speedy retrieval. Scalability, on the other hand, in a real-life scenario, scalability is very crucial. As data grows, the architecture must be scalable to accommodate increasing volume without compromising the performance. Access and analysis tools. Now that our data has a home, let's talk about how businesses access and derive insight. We have here the reporting tools that enables users to generate predefined reports, offering a snapshot of key metrics and trends. On the other hand, the analysis tools empower users to dive deeper. They can run ad hoc queries and perform complex analysis to extract valuable insight. Amidst all of this data, there's a silent hero, the metadata. Metadata, or the data about the data, is very crucial. It provides the context, helping users understand the origin, structures, and the relationship within the stored information. In real-life scenario, effective metadata governance ensures accuracy and reliability, making it linchpin of the data warehousing architecture. And there you have it, a snapshot of the architectures of a data warehousing. From diverse data sources to a powerful analysis tool, it is the backbone of informed decision-making in today's data-driven world. But remember that data warehousing is not just about storing data. It's about empowering business with meaningful insights for success and innovation.
Hello, good day everyone. When starting to create a new database, the database designer or database administrator need to carefully plan ahead. Mistake made in the planning phase could be very costly later on when the database is in the process of being put together and decisions have already been made on what kinds of technology or formats are to be used. To minimize the risk, the designer will usually start off by data modeling. The data model created will provide a blueprint for the finished database, ensure the consistency, and make sure that no elements have been forgotten. The models also make it easy to consult with all stakeholders and get feedback on what problem the database should solve. There are 3 stages in data modeling: conceptual, logical, and physical. Each stage brings the database closer to reality. First, we have the conceptual model. It sketches out the entities to be represented and determines what kinds of relationship exist between them. It deals with the scope and database to be created and define the general rules that need to be considered. The second one, we have the logical model. It will take these entities a step further and work out the details of their attributes and relationships. It defines the structure but does not concern itself with the technical aspect of how the database will be constructed. Lastly, we have the physical model. It moves from abstraction to reality and consider the database management technology to be used. The design of the table that will make
up the actual database and the key that will represent the relationship between this table.
Good day everyone! For this video, we will discuss what is dimensional modeling. Dimensional modeling is a data structure technique optimized for data storage in a data warehouse. The purpose of dimensional modeling is to optimize the database for faster retrieval of data. The concept of dimensional modeling is consists of fact and dimension tables. But before we compare the two of them, let me first discuss what is data model. Data model is a representation of how data is stored in a database. It is usually a diagram of the few tables and the relationship that exists between them. There are primarily two of operation in the database, which is the write and the read. Read operations. Read operations are performed to retrieve data from the storage system. These include querying data using SQL like queries or executing complex analytical operations on large data sets. By performing read operations, businesses can extract valuable insight from their data, make informed decisions, and gain a competitive advantage. Write operations. Write operations are essential for keeping data up to date and maintaining data integrity. They allow businesses to ingest new data into the data lakehouse, update existing records with the latest information, and delete obsolete data. Write operations are used to add, update, or delete data in the data lakehouse. This can involve inserting new records, updating existing records, or removing unwanted data. In short, write operation can be optimized with large number of smaller tables, while read operations can be optimized with small number of larger tables. A quick note, guys. The process of breaking down data into smaller tables is easy to manipulate them is called normalization. In the opposite of it, which is to consolidate many different tables into fewer but larger tables, are called denormalization. Now, let me compare the fact table and the dimensional table. Definition. Fact table measurements metrics or facts about a business's process, while the dimensional table companion table to the fact table that contains descriptive attributes to the use of query constraining. Characteristic. Fact table is located at the center of a star or snowflake schema and surrounded by dimensions, while the dimension table is connected to the fact table and located at the edges of a star or snowflake schema. Now, design. Fact table. Fact table is defined by their grain or its most atomic level, while the dimension table should be wordy, descriptive, complete, and quality assured. Type of data. Fact table. Fact table could contain information like sales against a set of dimensions like product and date. Dimensional table. Dimension table contains an attribute which describes the details of the dimensions. For example, product dimension can contain product ID, product category, and etc. Hierarchy. Fact table does not contain any hierarchy, while the dimension table contains hierarchies like location could contain country, pin code, states, or city. That's all for our topic for today. I hope you guys enjoy and learn on this video. Thank you.